Jones, who's the Vice President of the HPC business for NAG, and he's responsible for their HP services and consulting business. And I won't read the title of his talk because that would take too much time.
Thank you. So, Lloyd's about to start my clock and I have 26 minutes. Not 27, not 25, 26. So I'm going to talk about some of the lessons we've learned from the range of projects we've been involved in over the years in strategy and acquisition development projects for HPC systems. So I suppose I should start by saying, who am I talking about? In the context of this talk, I'm talking about NAG and our close partners at Red Oak Consulting in the UK. So Numerical Algorithms Group, or NAG, or NAG, depending upon how old you are, has been going for about 45 years. It was a spin-out from a university project, or multi-university project in the UK, although we now operate worldwide. We have expertise in high-performance computing, algorithms, and software engineering. And in fact, we were started by the bottom two of those things, bringing together algorithm software engineering to produce mathematical libraries. We now deliver consulting, services, training, software products, and I look after the HPC consulting and services business, which is pretty distinct from our software products. It's really focusing on our expertise. Our colleagues at Red Oak Consulting they're a niche HPC consulting firm in the UK, about 10 people in size. They've been going for about 20 years, although I've known the founder for longer than that. Again, they've got expertise in HPC. They do a lot of work around project delivery in HPC, and also they have a lot of experience in the classified environments in the UK. And they deliver consulting services. And between the two of us, we've got a lot of expertise and a lot of experience in a range of different HPC environments. We deliver that to customers through a whole range of different things. In the context of this talk, though, we're interested in those boxes that I've put into bold print. So we help customers to develop or review their HPC strategies and HPC plans. We help customers answer the common question, which is, how do I compare with best practice in HPC, by which they usually mean, how do I compare with my competitors? We help people buy HPC systems. That's the chunk of our work, really. That's the bulk of it. Make sure they get the best value, make sure they negotiate the market space. And also looking at evaluating and adopting new technologies, whether they're processor technologies or storage technologies or whatever. And we also do quite a bit of HPC project management, or specifically our colleagues at Red Oak do a lot of that. Like everybody else that provides HPC consulting and services, we also provide training courses. The usual range of programmer training courses. But unlike most other organizations, we're pretty unique in providing training courses not only for the programmer, but also for the people who are doing the management and the operation of HPC centers. So we run courses in essential HPC for the R&D manager. In other words, the vice president of engineering or whatever it is, who has to sign off on the HPC budget. What do they need to know about HPC to do that? We run a training course on HPC acquisition, on another one on benchmarking. We provide courses on service planning and delivery around HPC systems. So those are pretty unique aspects of the training space that aren't offered by most people. And the other thing I'd point out about NAG is that we're impartial and independent. We have a corporate structure that means that we are guaranteed to be impartial and independent forever, because when the company was spun out from the universities in the tail end of the 1960s, the academics who did so had no vision or concept of ever wanting to buy or sell a company. So they just simply didn't write any mechanism for buying and selling the company into the Articles of Association. So it's not just a case of how much money, it's a case of there is no way to buy NAG. We're independent, we're staying that way. Which is pretty useful. Our customers value that impartiality. So, with that as the introduction, what 40 HPC projects am I talking about? So these are, we did a little bit of a count up between ourselves and the guys at Red Oak, and we reckon we can easily get to 40 projects between the two of us over the last decade or two. Actually, the last decade, I think we stopped counting when we went further than that, of HPC strategy projects or HPC acquisition projects that have been delivered by the team between NAG and Red Oak Consulting. These have been around the world, almost everywhere except for, I think South America is the notable continent that's missing there. But other than that, we've done most of these around the world. In industry, government and academia, and probably 50-50 between industry and the private and the public sector. A range of different project sizes, so from order of $100,000 of customer spend on systems. Those are pretty rare. We don't tend to get too many projects of that scale. To order $100 million of customer spend on HPC systems, and those are also not too common, but they're a lot more common than the very small ones. And clearly it's usually somewhere in the middle. In our little count up, we tried to figure out what was the total projected spend of the projects that we were advising on over that time, and we got to $500 million pretty quickly, but we figured stretching it to $1 billion was too much, so we gave up counting. We just said $500 million will do. So in other words, over $500 million of HPC spend over the last decade has been advised by the team, either NAG or Red Oak, or a combination of the two of us. So that's where the experience comes from that's going to draw out these lessons. So with that in mind, in no particular order, I'm going to run through some of the things we've picked up and some of the things we draw out as common threads from having been involved in all of those projects. Out of curiosity, if I look around the room, I guess the room is probably, a lot of people in the room are vendors and suppliers rather than buyers. So it'd be interesting to see your feedback on this from the other side of the fence, where I'm essentially trying to advise your customers how to do better against you. So the first comment, or the first lesson we're doing, is that procurement is the easy bit. People tend to focus on going and buying the HPC system. But it is one relatively small part of a big process that requires a lot of work and a lot of experience and a lot of hard work and persistence throughout it. Usually it starts with some kind of development of a strategy at the front end that then goes on to things like building an investment case, in other words, persuading somebody to put some funding against that strategy and the vision of where you're going. Doing some market research. Is the market actually capable of delivering a solution against your wishes and your needs, or your wants and your needs? And bearing in mind that wants and needs are not usually the same thing. Thinking about infrastructure planning, planning how you're actually going to run the procurement. The procurement's a little bit in the middle, and then you've got to actually go and deliver it, do the infrastructure works, do acceptance testing, support it, measure how it's being used, report how that's done, prove the value, and so on. So procurement is that tiny little bit in the middle, which in some ways is the easy bit. However, it is the focus of most of the rest of this talk. So the stakeholders. This is our first lesson, if you like, and one of the things we build into the bid process or the project plan when we go and offer a consulting service to clients. Get a stakeholder management plan. Is a really important thing to do. Build a list. Write down a list of names of who the stakeholders are. Clearly write down a list of category groups of who the stakeholders are, but also a list of names. Check you've included everybody. You do not want to find out that somebody has a serious influence on the decision after you've done 6 months of work and you're about to try and sign a contract with somebody, only to find out another person within the company or the university infrastructure needs to sign off on it that you didn't realize. Build a list of stakeholders. Understand the politics of the stakeholders. Their personal politics, their interdivisional politics, their corporate politics. Again, the point at which you're negotiating contracts or considering negotiating contracts is not the time to find out that your vice principal of research refuses to ever buy a system from vendor X again. You need to know about that way up front. Engage early and often with your stakeholders. Really bring them into the process right at the front. Tell them what you're going to do and why and how you're going to go about it, and keep on updating them. And in that context, learn to communicate optimally with each stakeholder. They have different needs. Some of them just want to know the good news and the stories. Some of them just want to know the results of where you're up to. Some of them want to know every bit of technical detail and why you've made such decisions or why you're going the way you're doing. Learn that each one is different and how to prepare different material for each one. If you manage your stakeholders effectively, they will be absolutely invaluable support throughout the process. They will be your rock through it. They'll be the structure that gets you through all of the hard work and the hassle that is involved in large projects of this scale. Your goal is not to have them as some people you've got to convince you're doing the right job. Your goal is to have them as people who are there to support you to do the right job. You could say this about any project. This is not specific to HPC. This one is a little bit more specific to HPC. One of the first problems we come up against in this industry as a whole is really ourselves. And it's this one. I'm really clever. How hard can this be? Especially in the academic environment. I'm a very clever professor of astrophysics or whatever it is. How hard can it be to buy a HPC system of $20 million or whatever it is? And that phrase is far too common, or that thinking, that attitude is far too common, unfortunately. You think about it, just think about it in real life. Would you get in a car that was built by people who build cars for a living? Or would you look for a car that was built by a bright professor who's never really built a car before, but he's read lots of good lots of good books on the subject, and he's really good at astrophysics? Or maybe the other example I came up with was, would you get your plumbing fixed by a plumber who only does one job every 3 years? Or would you try and get somebody involved who does this every other week? And the thing to remember about all of this is not only find the experience in the buying HPC systems on the customer side, but remember, really the experience in this process lies with the suppliers and the vendors. Even those of us who buy or get involved in HPC procurement projects on a several times per year basis, we do not have the experience of those who are doing it on a monthly basis or more spread across different customers. And you should really bear this in mind, especially when it comes to the latter stages, when you're negotiating the contracts or negotiating the acceptance tests or all these things. They've got far more experience of you and far more adept at getting a better position for themselves out of it, just through your experience. Another lesson I like to bring to people is to remember that buying a HPC system, just bring your own experience from everyday life to it. Think about it. If you were going to go and buy a car, you would understand your budget, how much money you could afford from your family budget to buy a new car, what you needed, what you wanted, which again is probably not necessarily the same thing between what you need and you want. You'd do some research before going and talking to the salespeople. You'd make sure you know whether your $30,000 would buy you a scrap car or a top-end SUV or whatever. You'd explore some alternatives. You'd compare some alternatives. You wouldn't just buy on the sales pitch. You would not just walk into the first showroom that you come across and say, tell me how wonderful your product is and here's my checkbook. You'd take a test drive or a tour or whatever it is. You'd try the car out before you buy it. And then when it does, you'd have bought it and it turns up and it's delivered, you'd make sure it works properly. This is all your personal life experience. This is what you do. You'd be amazed about how much of that stuff does not go on when people are buying HPC systems. There are plenty of people I encounter in the consulting world, and consulting engagements, who jump to, we always buy from this person, we're just going to go and buy them. We want to buy a new system, we're just going to ring up vendor X and say, quote us a price for the next refresh, without any kind of competitive tension in there whatsoever. Or any exploration of what the alternative market is doing. And it may well be 5 years since the last time they explored the market alternatives in terms of technologies and stuff. This one is always an interesting one to build into any kind of project or any kind of mixing multiple people together in one endeavour, especially when some of them are externals. We all suffer or benefit, depending upon your point of view, from emotions and especially pride. The trick is not to let these get in the way of the right business decision or the best project execution. And this particularly comes up when things start to go wrong in the project. people tend to, the first reaction tends to be cover it up because I don't want anybody to find out how things are going on or why it's not working to what we originally said we were going to buy or whatever it is. Sometimes you're often protecting the wrong person. So if you take an example, you're in the acceptance phases of a system and it's not working. There is a point where you work with your vendor to make sure it works. There is also a point when you keeping quiet about that is only protecting the vendor and not yourself. There are other situations where you want to be prepared to back out and change your mind if it's going to secure value for your organization. A lot of people get locked into a mindset of we start here and we go here and we do this bit of the process and we move to the next bit and we move to the next bit. And there is no reason why you can't step back and say, hang on a minute, we're not happy with this phase, we're not happy with the value we're getting here or the quality it is, or we've realized that the market has shifted from when we first did the market requirements. It's okay to step back. If you're going to deliver value to the organization by doing so, it's okay to change your mind and do that. That was a lesson I learned very early in my career, and it's actually a very wise contracts officer who made us stop a procurement, throw it out and start again. And we got significantly better value for our money by doing that. And consider people as individuals. You can take what you want from that, but the simplest lesson is that everybody has different ways of dealing with stress or different ways of interacting with each other in a project. You may need the multiple expertise, but you have to recognize the personalities. Some people don't get on with each other. Take account of that in the project planning. Don't, again, specifically in the academic environment, this one comes up a lot. Don't be a technical snob. Don't assume that the only thing you're buying the HPC system on is its benchmark performance or its technical performance. Recognize the value of the non-technical inputs to the process. The legal team, the contracts team, the insurance people, the logistics, how's it actually going to get from A to B, how's it going to be implemented, the admin support. Think about those in the project plan or the procurement. They bring a lot of value to it. And realistically, the technical performance should only ever be one part of what is really a business decision to acquire a large facility. Having said that, technical performance is a very significant part of buying any HPC system. This is where you run applications on the system or specific codes to try and get an estimate of the expected performance on specific codes and data sets. It does not tell you whether system A is better than system B. It just tells you whether system A has got a better expected performance than system B on these specific codes running these specific data sets. It's a pretty constrained subset of the problem you're coming up with a result for. What it does do is enable you to feed some quantifiable information on cost and performance into the procurement decision. And that's valuable. More importantly, maybe, is that it gives you a mechanism to ensure that the delivered solution matches the promises in the bid. And in order to secure this, you have to make sure that your contractual process or your bidding process requires the vendors to commit to a benchmark performance. So the benchmarks the vendors submit in your procurement process should be what they're prepared to commit that they're able to achieve at the other end of the process when they're delivering a system. Not just what are the interesting technical features of this architecture and how show off what it might be able to do under ideal conditions. That doesn't help anybody really. It might be interesting on a technical basis, but it doesn't help a procurement process. And also insist that benchmarks are run on a realistic configuration. The system may run perfectly if the benchmark has exclusive access to the entire system with nothing else running on it, no batch system, bare metal access to do whatever they want. It's more interesting to find out how the system performs under realistic load, where perhaps there's multiple benchmark jobs running on the system at the same time, certainly running under batch schedulers and normal user mode operating systems and all the rest of it. And the other one is don't forget to benchmark the I/O. It's usually a really significant part of any infrastructure that's put in place that affects user performance more than anything else, and a lot of people don't include it in benchmarking as when they're trying to figure out how good the systems are. Think about the people on the other side of the procurement process, the bidders. They don't have some magic infinite budget that they can bring to the bidding processes. They do want to make some money. That may surprise some customers, but bidders are expecting to make some money out of this process. That's why they're submitting a bid to you. It costs time and money to put a bid together. It costs a lot of money to do benchmarks. Bidders in general will only bid if they think they've got a chance of winning. They will review that decision through the process. They will or can walk away before the process starts, before the bidding starts, during the bidding process starts, and afterwards, after they've promised to deliver you a system, and don't. All three of those things do happen and have happened. And you can find yourself starting out a procurement process with half a dozen bidders and then get down towards the end and you've only got maybe one bidder left in the race or two bidders left in the race, or worse, none. What is your plan if you have no bids? What is your plan if you only have one bid? Is that better or worse? You've got no negotiating power unless you manage to keep that relatively quiet from the one bidder. On bid scoring, come up with some kind of scoring matrix for how you're going to evaluate the bids. Ideally, before the procurement window opens, fix it very early on. Is your scoring matrix defendable? Can you justify to your stakeholders why you are scoring 4 gigabytes of memory more than 2 gigabytes of memory, and by how much? Is it a 2% increase in the score, or is it a 50% increase in the score? Why? What's the reason for that? Is it robust? In other words, what's the sensitivity to changes in the bids? Do you deliberately want your bid score to be very sensitive to a doubling of the memory, or do you want that to be a relatively low impact on the thing? You don't really want to measure that too much. Is your bid scoring system accepted by your stakeholders? Again, when you're about to tell everybody who the winning bid is not the time to find out that your main stakeholders don't agree with how you've chosen to score the bids. Get it accepted by everybody before you open the procurement window. Think of the infrastructure. Don't assume that it will be fine, we'll figure it out as we go along once we know what system we're getting. And this affects a huge number of projects. Well over half of the projects, in our experience, end up addressing some kind of potential delay caused by infrastructure. In spite of people talking about it up front, in spite of people planning for it, unexpected things happening with infrastructure or delays with infrastructure components are one of the biggest things you have to work around in projects. Plan for it up front, think about it. HPC infrastructure requirements are hard for the majority of data center people to realize that these aren't the same as normal IT racks. And everybody, even the HPC folk, underestimate how hard it is and what's going to go wrong and how the detail in the system that comes out. Acceptance testing. Think about the acceptance testing during the production of the requirements, not when you know what vendor solution you have and you're trying to figure out how to test it. Get the acceptance testing right at the beginning. You have a set of requirements for the system you're buying. Think how you're going to test those requirements before you open the procurement process, right at the beginning. As you're producing the requirements, how am I going to test this? What will be the acceptance test for this? Clearly you're going to refine it once you have a specific system that you're negotiating a contract around. But get the base level requirement acceptance testing defined right up at the front. Don't have soft acceptance criteria that equate to something like I'll know it when I see it. It's not useful, it's not fair to the vendor, it's not fair to your suppliers, it's not fair to your company in demonstrating that you've got good value for the money that's being spent. And the other one is make sure that the acceptance tests are finalized during the contract negotiations. In other words, before anybody signs the contract. Quite often this is one of the things that gets pushed towards the end of the contract negotiation process. And there will be a pressure to get the contract signed, either because you've been negotiating for months and you're getting a bit fed up with it, or because you have a particular deadline where you want to announce the system, or you need to get the system into place. And you often end up with somebody trying to push for a statement along the lines of, each party will act in good faith to agree the acceptance tests. All you're doing is pushing a small problem from now into a much bigger problem closer to the time. And usually that closer to the time means you're going to try and agree it the day before the acceptance tests are due to run, and there's only one person who has the advantage in that situation, and it's the supplier, not the customer. Project management. Appoint a proper, by which I mean a professional, customer-side project manager. Not just somebody who's taken time out of their job as a researcher to have a go at project management on this large-scale system. Either get one from elsewhere within your organization or appoint one under contract. It was money well spent having professional project management. Somebody who does this for a living, project management. Get them appointed, even for a short amount of time. Insist on a named supplier-side project manager. Again, a contract signature. Just in the same way you need a proper project manager on the customer side, you need a proper project manager on the supplier side, particularly if it's a complex installation. Get a named person. Know who's going to be responsible. Partly so that you have confidence that the vendor really does have somebody capable and ready to do this. Don't allow phrases like a qualified project manager will be appointed. Again, you're just deferring the risk of this problem until much later on, until it's too late to deal with it. Use the same rigor as you would for your own project manager. Insist on a CV or a resume, maybe even an interview for the potential project manager. This person is going to be responsible for changes, that potentially significant changes to your infrastructure, implementation, and the timescales of implementation of potentially tens of millions of dollars of your money. You want to know how good that person is and whether they've got the experience. Having a right of veto over supplier stuff allocated to the contracts is usually useless in most circumstances. By the time you've discovered that the project manager is useless, it's way too late. The project's late and the damage has been done. Try and evaluate them up front. That veto over supplier staff is useful if you need to remove somebody for security reasons or other reasons like that, but for reasons of inability to do the job is usually a bit too late. Failure. Stuff will fail. I haven't yet met the perfect system or the perfect installation or the perfect project execution. Stuff does go wrong. Be very clear during the contract negotiations and the contract formulation what a failure by the supplier means. Have a clearly understood impact on your customers, on your business, of what the failure to meet the performance targets are, what the failure to meet the timescales are, features, whatever, and then get written into the contract appropriate incentives for the supplier to succeed and to meet both the initial targets but also the ongoing performance targets of the system. Get them written into the contract, and again, don't be pushed to leave those until later. We'll agree appropriate performance targets. Make sure the incentives are correct and meaningful. A $200 a day penalty is neither here nor there. This one's difficult under procurement legislation sometimes, but you have to take it into account. It's just realistic. Be realistic about different suppliers. Some suppliers are easier to deal with than others. It's just true. There are some companies, HPC companies out there, who you know will take months to conclude contract negotiations. There are others who you are reasonably confident can get it done in 2 weeks. Take account of that, and maybe the contract negotiations will be more combative with one vendor and maybe more cooperative with another. Cooperative doesn't necessarily mean they're still not trying to screw you. Ensure that the ease of the commercial discussions is scored in the bid evaluation. It is perfectly legitimate to have a score for this bidder is likely to be much easier to negotiate a contract with. That is part of the business decision of working with them. And again, not all suppliers are equal. Some suppliers are more capable than others. Score that. The capability varies during the scale. There may be some suppliers who are very, very capable and competent at the level of 1,000 nodes who do not have the same capability and experience at the level of 10,000 nodes. Score that as a delivery risk in the bid evaluation. They're not all capable of delivering on what they write down on the piece of paper to the same standards. Time, which neatly matches with the fact that my time is balancing perfectly. This is the last slide. Everybody, especially the suppliers, but more especially, in fact, the customers, will be optimistic about timescales. We all hope this is going to go according to plan. We all hope it's going to happen in the best possible time. Stuff happens, and I'm sure you're aware of a more colourful version of that. It just happens. Stuff happens. Stuff goes wrong. Stuff you wouldn't expect, whether it's extreme weather events or people resigning in the middle of the job, or just technical failures or software bugs or companies buying each other. Stuff happens. Build risk time into the project plan. Never ever be persuaded along lines of this is so important we just have to make it work on time this time to the shortest possible time. Time is one of those things that's awfully hard to replace once it's gone. It's a one-way street. Build risk time into the project plan, plenty of it. And so with that, my conclusions, experience matters. Don't rely on how hard can it be, because the answer is very. Ask for help. There's lots of people who do this on a regular basis, your colleagues or your peers at other institutions, or people who do it on a regular basis or have managed large-scale projects before. Ask for their help, ask for their advice, ask for their input. Most people are more than willing to provide some advice and help on this, either for free or people like ourselves that charge you for it. Benefit from the mistakes and successes of others. Don't make all the mistakes yourself the first time around. Thank you.